Hello students, welcome to Educate. In the last class, we have discussed till the basic strength of the amines. Now we will discuss the other chemical properties. Of the chemical properties of amines, we have already discussed about the basic strength. Now we will discuss the other reactions performed by the amines. Let's see. First one is alkylation. Alkylation means alkyl group will join. That is alkylation. So let's see what happened here. The reactions you are already familiar, but even though I am discussing here. Suppose this one amine, when that will react with a haloalkane. Again, I am going on the process. What happened if you will keep that in your mind, and if you will practice that from where to where the attraction will take place and where the cleavage of bond will take place. In addition to that, after the cleavage of bond, the product will be stable or not. Then in the examination of IIT, you will solve those questions. Of the NEET examination also, that will be very helpful. And in addition to that, for the 12th board examination, if you are considering only about the 12th board examination, then you will feel easy to predict what will be the product. So let's see first of all, so that I am discussing here what is here, and you are already familiar with that, so you can predict also very easy. What happened here? Here in halogen, you know already there will be slightly negative charge on the halogen and slightly positive charge on the carbon atom, and to the nitrogen there is lone pair electron. So this nitrogen will get attracted toward this carbon. So compound become what happened here, when chlorine will release from there, that will be in the form of Cl minus, and the nitrogen will give one electron to the carbon, and through other electron it will do bond formation. So there will be loss of one electron for this nitrogen. So that's why a positive charge will appear on this nitrogen. And this amine, this one ammonium amine ion and the chloride ion will held together through electrostatic force of attraction. Then after one of the hydrogen of bonded to the nitrogen, that will get bonded to the chlorine and form HCl. Why only this hydrogen? Why not from here? Because in this case here, there is positive charge on the nitrogen. So nitrogen will attract this shared pair of electron of NH bond. Nitrogen will attract this shared pair of electron of NH bond. So it will release as H plus ion. This H plus ion will combine to this Cl minus and will form HCl. So only left here, this remaining portion will remain there, positive charge will get neutralized. So compound will be stable. Secondary amine will form. So primary amine, primary amine will react when react with haloalkane. There will be formation of secondary amine. In the same way, tertiary amine will also form. Same process here. This one here. So same, chlorine slightly negative charge, carbon slightly positive charge, and at the nitrogen there is again lone pair electron. So this nitrogen will get combined to this carbon, forming this Cl minus will release, and here positive charge will appear on the nitrogen atom. So positive charge will appear on this nitrogen atom. So what will happen then? After hydrogen will release, this hydrogen will combine to this that Cl minus. So the primary amine will convert it to the secondary amine, and then after in tertiary amine. So that is here alkylation. So amines undergo in alkylation. Same will happen in case of acylation. Okay, this one is, so primary amine firstly react with haloalkane. There will be formation of secondary amine. The secondary amine will further react with haloalkane and there will be formation of tertiary amine. Okay, so now let's see about acylation. In acylation, you can watch out from here also, from the book. What is here? In acylation here, this compound, it's ethanamine and this one is ethyl chloride. This compound's name is ethyl chloride. Okay, what happened here? This oxygen will take, that means this oxygen attached to the acylic carbon atom. This oxygen will attract the pi electron towards itself. So here will be negative charge. This carbon will have positive charge. There is a lone pair of electron at this nitrogen atom. So this nitrogen will get attracted toward this carbon. What happened? This nitrogen will give one electron to this carbon and through other electron it will do bond formation. So what happened? There will be loss of one electron for this nitrogen. That's why a positive charge will appear on this nitrogen. Same procedure which we have applied in case of alkylation, same procedure will apply here also. So what happened? Here positive charge on this nitrogen. So when positive charge on this nitrogen is here, so then after this nitrogen will attract the shared pair of electron of NH bond. So here this will release as H plus ion. So H plus ion released, that will combine with the Cl minus released from here. That's why HCl4. Okay, this reaction here. So maybe you understood or not, I don't know. So here just we go on the secondary amine. Okay, secondary amine is here when react. Okay, written here already. Why the name is here N-ethyl ethanamine? So for whole of this, that will be total number of carbon is 2 and amino group is attached here. So that is when nitrogen bonded to acylic carbon, that is amide. When nitrogen bonded to acylic carbon, then that is called amide. So here for this whole of them we will write ethanamide, and it is, so that's why written ethanamide, and this is substituent. This C2H5 is substituent. This C2H5 substituent, and but that is not bonded to the carbon, that is bonded to the nitrogen. So that's why we have written N-ethyl ethanamide. So the name of the compound will be N-ethyl ethanamide because ethyl group is bonded to the nitrogen. So that's why N-ethyl, and whole of this compound will be called ethanamide because number of carbon atom is 2 and nitrogen is bonded to the acylic carbon. So that's why name is N-ethyl ethanamide. About the secondary amine also I am telling you here how to do the reactions. So same procedure here also. So when I said tell you about the secondary amine, then very easily you will solve that of the primary amine. C2H5 taken. So okay, I am taking C2H5. This is secondary amine that reacts with here ethyl chloride. So what happened here? This oxygen attract the pi electron towards itself. So here will be negative charge on the oxygen and positive charge on the carbon. You are already familiar. Now lone pair of electron, there is lone pair of electron at the nitrogen atom. So this nitrogen will attract toward this carbon because there is positive charge and electron negative charge. So positive charge get attracted towards this negative charge. So what will happen? This nitrogen will donate one electron to this carbon and through other electron it will do bond formation. So for this nitrogen there will be loss of one electron. That's why one positive charge will appear on that nitrogen. So compound will be so when this nitrogen will get bond to this carbon, so bond will dissociate from here, Cl minus. To maintain the valency, Cl minus will release from there. So this chlorine will take its own electron as well as electron of the carbon atom. So that will release as Cl minus. So this one get bonded to this acyclic carbon. So here C double bond O. Watch out here. This C double bond O and to this C double bond O. CS3 is attached. So here CS3. And here is positive charge and Cl minus. Then after, to neutralize this positive charge, the nitrogen will take the electron of this NH bond, sigmoid bond. So here H plus will release, that will combine with Cl minus and will form HCl. Again, since nitrogen have taken the electron of its own as well as that of the hydrogen, so again one lone pair of electron will appear on this nitrogen. Okay, so what will be there? Product will be write the IPAC name of this compound. I am giving you 1 minute time. Write the IPAC name of this compound. What will be that? I am giving you one minute time. Written. That was not tough. Okay, how to write that? Let's see. Nitrogen C double bond O CS3. So when nitrogen is bonded to acyclic carbon, so for whole of them, the word will be amide. Okay, so 2 carbon here, so that's why ethanamide. And here ethyl group is bonded to this nitrogen, and here also ethyl group is bonded to this nitrogen. So that's why NN diethyl, because ethyl group is not bonded to the carbon, that is bonded to the nitrogen. So that's why NN diethyl will have to write. So its name will be here NN diethyl and here ethanamide. So name is, okay, here might be written, yes, NN diethyl ethanamide. That's why the compound. Same here, benzamide also react with acetic, okay, this compound ethanoic anhydride here. So ethanoic anhydride, that is the IPAC name, and acetic anhydride will be the common name. Ethanoic anhydride, it is IPAC name, and common name will be acetic anhydride. Okay guys, now let's see about this one, about this reaction we discuss. And you could do by yourself also, but let's see. It is aniline, benzenamide or aniline. So let's see structure, draw. Aniline here, that reacts with acetic anhydride. Same procedure, where to go? So this oxygen attacks the pi electron towards itself. So here negative charge, here positive charge. In the same way, that can process with this one also. So this oxygen will attack the pi electron. So here negative charge, here positive charge. So what happened? This carbon will act as electrophilic center, and this carbon could also act as electrophilic center. There is a lone pair of electron at the nitrogen, you are already aware. So this lone pair of electron will get attracted toward this carbon. So what will happen? Here will be so when this nitrogen will get bonded to this acyclic carbon, bond will dissociate from here. So that will be CS3 COO minus here. So that will be here C double bond O CS3, and its name will be CS3 C double bond O minus. That will be. Then after here is positive charge, because what happened? Same. This nitrogen donate one electron to the carbon, and through other electron it do bond formation. So there is loss of one electron for this nitrogen. So as there will be loss of one electron for this nitrogen, that's why one positive charge will appear on this nitrogen. Then after to attract here, to neutralize them, the nitrogen will take the shared pair of electron of NH bond. So it will release as H plus ion. Because for the hydrogen, there will be loss of one electron. That's why it will release as H plus ion. So this H plus ion released, that will combine to this oxygen. So what will be the product? This will remain. What will be the product? This one, and hydrogen released. So that become. So here ethanoic acid form. And here, this what's the IPAC name of this compound? Let's see. I have told you that whenever the open chain will contain the functional group, then the name of the compound will be based on the open chain, and the cyclic group will consider as substituent. Cyclic group here is benzene. So benzene will act as substituent, and the word used for the benzene when it act as substituent is phenyl. So phenyl is attached to nitrogen. So that's why it will be called N-phenyl. And here to whole of them, it's amide. In this amide, C double bond O and nitrogen. Here nitrogen is bonded to acylic carbon. So that's why this compound is amide. So nitrogen is bonded to this amide. So that's why here in this amide there is two carbon. So that's why it will be ethanamide. So main name is ethanamide, and phenyl is attached to the nitrogen. That's why N-phenyl ethanamide. So that will be written N-phenyl ethanamide. That's why. Acetonitrile, it is the common name. N-phenyl ethanamide, IPAC name. This one is IPAC name, and acetonamide, that is common name. Okay, guys, easy it is. No, it's also react with benzamide. So should I do? You do that by yourself. If anyone will feel difficulty, because same procedure apply everywhere. So that's why I am leaving on this one on you. If anyone, even though this one is so much high, so much easy that anyone will not feel difficulty, but if anyone will feel difficulty, may ask by writing the comment in the comment box. Then after I shall discuss about that. Okay, so let's see. Carbylamine reaction. That reaction is too much important, guys. Carbylamine reaction is too much important because this carbylamine reaction is used to predict. The carbylamine reaction is used to distinguish the primary amine from other class of amine. Carbylamine reaction is used to distinguish primary amine, from the other class of amine. And how the reaction takes place? Let's see. First of all, this one is this carbylamine reaction. It is used that is secondary amine or tertiary amine. What is that? So if a number of amines has been given and you will have to predict which amine is primary, then you will have to perform the carbylamine reaction. What is that? How the reaction is taking place? Let's see. Suppose this is here, one amine is this one, that's react with chloroform. Chloroform is CHCl3. this one, and 3 moles of KOH. So 3 moles of KOH. So let's see. So 1 chlorine combined with this potassium form KCl. In the same way, this potassium will combine to this chlorine form KCl. After that, what happened? This hydrogen combined to this OH. This hydrogen combined to this OH, form H2O, and this chlorine here, 3 moles of chlorine, 1, 2, 3. So this chlorine also combined with this potassium, so form KCl. So carbon valency left, that will get bound to this nitrogen, and there will be formation of CH3, CH2, CH2, and C. And so here 1 mole KCl, second mole KCl, third mole KCl. So 3 mole of KCl form, chloroform here. So all the 3 chlorine of the chloroform, that will combine with the 3 potassium of 3 different KOH molecule. So there will be formation of 3 moles of KCl, and the hydrogen left here, this hydrogen combined to this OH, this hydrogen combined to this OH, and this hydrogen combined to this OH. So 3 moles of H2O will form, and this carbon will get bound to this nitrogen. So there will be 3 moles of H2. So this one is isocyanide test, and it will have a foul smell. It will have foul smell. So it is foul smelling. So foul smelling, isocyanide here, foul smelling. That's why you can predict if you will react the amines with the mixture of chloroform and that of KOH, then foul smelling substance will form, and if foul smelling substance will form, and if the amines will react with this one and no, when you mix and no foul smelling substance will form, then that is not primary amine. So primary amine when react with KOH and chloroform, then when primary amine react with KOH and the chloroform, then a foul smelling substance, that is isocyanide, will form. So IUPAC name will be here propyl 3 carbon, so propyl isocyanide. So this foul smelling substance will form. So that is used. Okay, take another example. If there is taken R, so same here, R, there is R and H2 that react with chloroform, and 3 moles of KOH. So this chlorine combined with this potassium form KCl. This chlorine combined with this potassium form KCl. This chlorine also combined with this potassium will form KOH. So there is 2 hydrogen here, 2 hydrogen and this 3 hydrogen. This 3 hydrogen will combine with this 3 OH and forms 3 H2O, 3 KCl, and this carbon will get bound to this nitrogen. So that become R and C. Alkyl isocyanide form, it has foul smell. Okay, this carbylamine reaction is also called isocyanide test, because during this reaction isocyanide has been formed. That's why this reaction is also called isocyanide test. Now let's see reaction with nitrous acid. So about the diazonium salt formation, we have discussed a number of times about the diazonium salt formation. So here diazonium salt form, and it is highly unstable. Yeah, when primary amine, aliphatic amines, when aliphatic amines react with the nitrous acid, HNO2, that is called nitrous acid. And how the nitrous acid has been formed? By reacting sodium nitrite with HCl. Sodium has combined with this chlorine, form NaCl, and hydrogen get combined to this NO2. Because sodium is positive, chlorine is negative. So sodium will combine with chlorine, and here NO2 will have negative charge and hydrogen has the positive charge. So hydrogen will combine with HNO2, NO2. So that will form HNO2 and NaC. That's why HNO2 formed by this one. Okay, how the reaction takes place? I think hope anyone will not feel difficulty. So the diazoxide salt form, and then after, when the diazoxide salt will be treated with water, then alcohol will form, nitrogen gas will evolve, and HCl will form. This nitrogen gas evolve that will be used for the estimation of amino acid in protein. Okay, this reaction with nitrous acid in amino, you know, protein is the polymer of amino acids, and amino acids are the substance in which the NH2 group and the COOH group bonded to the same carbon atom, and here alkyl group part of this one. So and this one amino group here is there. So this one, that means reaction with nitrous acid is used to detect estimation of amino acids and protein. Okay, amino acids and protein, that is. Amino acid is that. Amino acid is the compound in which the amino group and the carboxylic acid group bonded to the same carbon atom. That is amino acid. So that is here. So this one used, so that it is used, this reaction is used for the estimation of amino acids and protein, used to estimate this one. Now aromatic amines also react with this one, and here you know diazoxide salt. This diazoxide salt is used to prepare a number of compounds. Sandmeier's reaction, recall that? So about that we have discussed already. Reaction, let's see here this reaction. It is very important, Hinsberg's reagent. Reaction with Hinsberg's reagent. The aryl sulfonyl chloride is called Hinsberg's reagent. It is why here commonly it is aryl group. So aryl, it is sulfonyl and chloride. So aryl sulfonyl chloride. This aryl sulfonyl chloride, that is called Hinsberg's reagent. It is called Hinsberg's reagent. Same procedure again, watch out about that. We have discussed, which we have discussed here. Here sulfur, from the sulfur, oxygen will attack the electron. So here negative charge. Here same. Here negative charge. So high positive charge on the sulfur. What happened? There is a lone pair of electron at the nitrogen. So here is positive charge. At the sulfur there is positive charge, and at nitrogen there is one lone pair of electron. At the nitrogen there is a lone pair of electron. So that's why this nitrogen will get attracted toward this sulfur. Okay, so what will happen? Here aryl sulfonyl chloride, so here this benzene here. And Cl minus will reach from here. So here nitrogen, 2 hydrogen and C2H5. This one positive charge. Now to neutralize this positive charge, then after this H plus sign, this nitrogen will attack the said pair of electron of NH bond. So this hydrogen will release H plus sign, that will combine with chlorine and form HCl. So here again a lone pair of electron will be. In this compound here, its name is N-ethyl benzene sulfonamide. Why an ethyl benzene sulfonamide? This one holds. Nitrogen is not bonded to C double bond O. It is bonded to sulfonyl group. So that's why here sulfonamide. Whole this compound will be sulfonamide. And here whole this group is sulfonamide. And then after this, here benzene attached here. So that's why ethyl group attached here to the nitrogen. So that's why an ethyl. And here it's a benzene and this whole. This one will be benzene. Sulfonamide, and this is nitrogen is bonded to this. Here ethyl group is bonded to the nitrogen. So that's why an ethyl benzene sulfonamide. That's why the name is. Here there is in this compound there is one hydrogen atom. There is one hydrogen atom attached to the nitrogen. And here when the sulfur will attach the electron, there will be negative charge, and here same, here negative charge. So magnitude of positive charge on the nitrogen atom will be too much high. Since the doubly bonded oxygen will attract the pi electron towards itself, and there is two oxygen. So magnitude of positive charge on the sulfur atom will be very high. So as a result, what will happen? As a result, the share pair of electron here present. As a result, what happened? The lone pair of electron present at the nitrogen, that will come here for the double bond formation. So then after, what's the option it has? It will have to attract this shared pair of electron of NH. So this compound is acidic. This compound is acidic. So this compound is acidic. So as a result, it will be acidic. So it will be soluble in alkali. Okay. So it will be acidic and hence soluble in alkali. Okay. Second compound here. What is here? Reaction with aryl sulfonyl chloride or Hinsberg's reagent. When the primary amine will react with the Hinsberg's reagent, then the product form will be soluble in alkali. The secondary amine when react with Hinsberg's reagent, then the product will be insoluble in alkali. And tertiary amine do not react with the Hinsberg's reagent. Okay, so Hinsberg's reagent, reaction with Hinsberg's reagent, it is used to distinguish primary amine, secondary amine and tertiary amine. Their carbylamine reaction, that was used only to distinguish the primary amine. The carbylamine reaction was used to distinguish primary amine. So if the compound will react with the mixture of chloroform and the KOH, then there is a foul smelling substance form, then you can say that this compound is primary amine. But about secondary amine, and if the compound, that means amine, will not react with the mixture of chloroform and the KOH, then that will be not primary amine. So that will be not primary amine, you can say, but you cannot say that is the secondary amine or the tertiary amine. But among the Hinsberg's reagent, when the compound react with Hinsberg's reagent and the product formed is soluble in alkali, then the compound will be primary amine. If the compound react with Hinsberg's reagent and the product formed is not soluble in water, then that will be secondary amine. And if the amine will not react with Hinsberg's reagent, then that will be tertiary amine. Okay, so yeah, in the same way, secondary amine, same procedure reaction here. So as I have told you by writing there, here I shall tell you directly. So lone pair of electron here nitrogen, here negative charge on the oxygen, here negative charge on the oxygen, so positive charge on the sulfur. This nitrogen get attracted, chlorine will release from there, and for then after hydrogen will also release, so that will form. So its name will be, what is here? It is benzene sulfonamide, and the 2-ethyl group is bonded to the nitrogen. So that's why it will be called N-diethyl benzene sulfonamide. Okay, so this product form and the tertiary amine do not react with Hinsberg's reagent. Okay, tertiary means do not react with Hinsberg's reagent. So you should write that the Hinsberg's reagent is used to distinguish the types of amine, that is primary, secondary or tertiary. The primary amines reacts with Hinsberg's reagent and the product formed will be soluble in alkali. The secondary amine will react with Hinsberg's reagent and the product formed will be insoluble in alkali. The tertiary amine do not react with Hinsberg's reagent. Okay, why this one here, secondary amine, not soluble in alkali? Let's see firstly. Listen here. In this case, in secondary when secondary amine reacts with the Hinsberg's reagent, this compound form and diethyl sulfonamide, there is no nitrogen attached to the nitrogen. There is no hydrogen attached to the nitrogen. So there is a stress of bond. There is a stress of bond here on the nitrogen. But since hydrogen is not available, so that's why this compound will be not soluble in water. So when the lone pair of electron will come here for the double bond formation. So electron will supply from this side and this side. So during that course, this compound will stabilize itself. Now let's see electrophilic substitution reaction in haloarine. Electrophilic substitution. So in aniline, you already know that the lone pair of electron present at the nitrogen that delocalizes inside the benzene. So when that delocalizes inside the benzene, then that will be ortho and para directing. So when you react, and here in this case also, and the nitrogen frequently donate their lone pair of electron in the benzene. So there will be significant electron cloud density at both the ortho position as well as at the para position. So what happened? So much electron cloud density here there. So the electrophile attached at both the ortho position and at para position. So like that here, when aniline react with bromine, then at this two ortho position and at this para position, so bromine gets bonded. Here hydrogen released from there, that will react with another bromine from HBr. Okay. Now, if you want to prepare the mono substituted bromoaniline, if you want to prepare mono substituted bromoaniline, then you will have to involve the lone pair of electron present at the nitrogen atom in the bond formation. Or in other way, you will have to decrease the electron cloud density at the nitrogen atom. So how's the electron cloud density will decrease? So we react with acid anhydride. We firstly, to prepare the mono substituted bromo derivative of aniline, first of all, the aniline will react the aniline with the acid anhydride. So what will happen firstly? So when acid anhydride react with aniline, then what happened? You are already familiar. Here, how the reaction taking place, that's I am not telling, because already I have discussed a number of times. So there acetic anhydride like this one, CH3, C double bond O and O here, and here also C double bond O and CH3. So either this group will get bonded to the nitrogen, or this group will get bonded to this nitrogen. That get bonded. How does that get bonded? Recall that previous reactions. Okay. Now, firstly, and then after, that means when the aniline react with acid anhydride, first this compound form, and with this compound, the bromine will react. Then after, firstly we will react the aniline with the acid anhydride, and then after we will add the bromine. As a result, since electron cloud density at the nitrogen atom will decrease. How that will decrease, I tell you later after 2 minutes. So how's here? So when this compound here, electron cloud density at the nitrogen atom will decrease. So when electron cloud density at the nitrogen will decrease, so the electron of nitrogen will not frequently delocalize inside the benzene. So only two options. So bromine will either combine to the ortho position or at para position. And since the para substituted product is the stable product, that's why bromine will bond to only para position and not to ortho position. Okay, and then after this one para substitute bromo derivative of aniline form, then after it will treated with acid or the alkali. As a result, what will happen? This group will release from there and hydrogen will get bonded. Okay, now let's see how is the electron cloud density at the nitrogen atom will decrease. You could predict by yourself also, but even though I am telling here, listen. Here this acylic from this acylic carbon, the oxygen atom will attract the electron. The oxygen atom will attract the electron. Here negative charge, here positive charge. So to compensate this positive charge, the lone pair of electron present here, that will come here for the double bond formation. Here oxygen will attract the pi electron, here negative charge on the oxygen, and there will be positive charge on the carbon. So lone pair of electron present at the nitrogen, that will come here for the double bond formation. So electron cloud density at the nitrogen atom will decrease. Okay. Okay, think about these questions I am telling you. First of all, watch out, what is that? हाँ सब कुछ बोल रहे थे Listen here, when nitration will be done of the name. Okay, I think a number of guys have attempted this one and have not understood. So what happened here, this aniline, when reacts with HNO3 in presence of H2SO4, what happened here, there will be formation of ortho substituted, para substituted, in addition to that, meta substituted product. And just compare. The ortho substituted nitro derivative of aniline is in bigger amount, and here there is significant amount of meta substituted nitro derivative of aniline. What's the reason here? Because aniline when you will react with HNO3 and H2SO4, aniline here, you take HNO3, this one, and H2SO4 and H2SO4. This H2SO4 will dissociate into H plus ion and HSO4 minus. H2SO4 dissociate into H plus and HSO4 minus. This H plus combined to this nitrogen. H2SO4, you know, a very strong acid. Everyone know. I think who have not studied chemistry, they also know what is H2SO4. That is, H2SO4 is an acid. Who have not studied the chemistry, he can also tell. So here H plus here will combine to this nitrogen. So there will be formation of NH3 plus. Now there is positive charge on the nitrogen, so it will attract the pi electron towards itself. So NH3 plus will withdraw the electron from the benzene. As a result, the electron cloud density at the ortho as well as at the para position will decrease, and hence the NH3 plus will act as will act as meta directing group. Okay, so that's the question asked, why during the nitration of aniline there will be formation of meta substituted product in significant amount. So answer is that the H plus ion released from H2SO4 that combined with NH2 and form anilinium ion. This is called anilinium ion. So in anilinium ion, the NH3 plus will act as electron withdrawing group and hence will give the position to the electrophile at meta position. Okay, now here what's the process? Okay, to calculate here only ortho and para directing group. How we will prepare only ortho and para substituted nitro derivative of aniline. Only ortho and para, or only para substituted product. Since ortho will be too much less, para only, because para substituted product is more stable. So what to do here? First of all, in the same way, you decrease the electron cloud density at the nitrogen. Here, how? By reacting with acid anhydride. So this compound form, and what's the name here? You predict, and then after do the nitration. So there will be formation of meta substituted nitro derivative of aniline. Then after pass out the acid or the alkali. So during that course, you can form the only para substituted product. Now let's see sulfonation. What here? Sulfonation here. Then after. So sulfonation, what happened in sulfonation? The H2SO4 that dissociate into the H2SO4 that will dissociate into H plus and HSO4 minus. So this H plus will combine to this nitrogen, that become NH3 plus, and HSO4 minus that will get combined to this para position. So that's why here what happened? There is formation of here NH3 plus, firstly HSO4 minus this one, but this HSO4 minus go to this para position. This one. Of this compound, sulfanilic acid, its name is sulfanilic acid. Of this sulfanilic acid, the H plus ion go to this NH2, that become NH3 plus and NSO3 minus. This one is charge suppression there is, and that is called Witter ion. This one is Witter ion. Okay. About this question here, basic strength, let's see. We have already discussed about the chemical properties of aniline. Now based on that, here is some reactions. Someone I am hinting you, and remaining you will have to do by yourself. But this one is quite easy, you could solve by yourself. So let's see. I am going through this one fastly. Basic strength I have already discussed. In aqueous state, what is that? In vapor phase or in evaporative solvent, what would be that? So very easy questions, you do by yourself. Next one is here. Complete the following acid-base reactions and name the product. Name the product here. So what happened here? Acid-base reaction. So what you have already studied, it's a base. So hydrogen finally the chlorine combined with hydrogen form HCl. The chlorine has combined with this one. H plus will get. Okay, I am writing that here. So there is lone pair atom. H plus will get bonded to here. So compound become here positive charge, and to this one Cl minus will attracted through the electrostatic force of attraction. Then after again with this amine, the other amine, with this aminium ion, the other amine will react same. This release from here, and finally HCl will form. So I am writing in the same step because you are already familiar. Then after this will get attracted and form, and secondary amine will form, and in the same way tertiary amine will form. Okay. Now this one done. We have positive charge here, NH positive here will be H plus here, here will be there. Now alkylation we have discussed right now, so you do by yourself. Benzyl chloride we have discussed right now. C3H9 and IPAC nomenclature. That's firstly you try at your home. Then after I shall discuss in the later on. Because here this question is important not only for the 12th board examination but for the NEET examination also, as well as for the IIT main examination. More important for the NEET examination and less, but its importance should not be denied for the main examination. So about that we will discuss also later on. So that was about the reactions chemical properties of amines. From diazoxide salt we will discuss in the next class. Okay, so it's all for this class. In the next class we will discuss from diazoxide salts, and diazoxide salts is a very important compound, and of all the chapters of the organic chemistry, this chapter is quite important. Here of the chapter aldehyde and ketone, one frequently asked question is from the roadmap, which is of 5 marks. That is the most important. And here, because in these reactions you have observed that a number of reactions there is which is used to distinguish. So this chapter is quite important. So whenever you watch out this video, you watch out seriously. Take pen and paper along with you when you watch out the video of the YouTube channel Educate, and that will be beneficial for you. So it's all. Thank you, Team Educate.